Today there are some things we wanted to cover here on mainly the model in place function inside Revit, and also 3D import capabilities. I'll cite you the scenarios later, how to change line weights, and how to add in the 2D functions and how to apply them again. And also the part on IFC export and import, in case you are using a format in which you need to cross platform. Somebody uses AutoCAD, for example, that you need to export it to a particular format. All right, that will be the scenario. First things first, let's jump to 3D Studio Max first for now. Okay, this first part of the topic is an excuse. 3D Studio Max is an excuse at the moment to become an example when you have a scenario like that. Like for example, students using Rhino. Rhino is great for doing funky forms, funky whatever. And then you use the contour function, and then you contour this whole thing, you chop, 10,000 section comes out, and then you do ribbings with it and so on. Wow, very nice form, 3D and all that. Parametric. The thing about this is, after you do that, the Rhino part ends. Rhino gives you all the beautiful form and all that, but the trouble with using Rhino is you can't really quite document properly. And if you have to import all those things using AutoCAD, you just feel very suicidal, because it's very depressing to have to comb through that many 3D points and everything. Very, very painful. So therefore, in order to do this, we have also developed ways and means to try to help you out. Like for example here, if you ever encounter a situation like this, but then the thing about this is Revit, it's great for doing documentation work. You can do scheduling, annotations, material specification, dimensioning and all that easily. The trouble with this is Revit's 3D modeling capabilities remains 4 or 5 functions. Compared to perhaps using Rhino, using 3D Studio Max, you have tons of all these tools in which even me, I don't know all the functions inside 3D Studio Max right up to now at this point. So it can make our lives quite difficult in that sense, where we have to work in cross platforms. So let's try to open up one of these examples here under Organic Cabinet. Let's try opening up one of these here, for example. If you look at this right now, everything can start off with just using a line. Alright, in let's say 3D Studio Max, everything is just a line, and then what we do is we can extrude this line now. Okay, once we extrude this line, we can give it, say, thickness, and once we give it thickness, we just curve the form, and then using FFD, we just bend it a little bit, and that's it. Things like that will only take us less than 5 minutes to work on in either 3D Studio Max or Rhino. Just like that, we're done. The thing about this is, if you were to do this inside Revit, it will take you hours, if not days, if not achievable at all. Okay, that is the problem. So therefore, in order to do this, sometimes it is simply put it this way, it is just easier for us to build it in any other software other than that. It could be from 3D Studio Max, it could be from Rhino, or it could be, if you are a SketchUp expert, straight away from SketchUp, and that's it. So this today's topic, a lot of focus is going to be on this part where after you have done up all these things, how do you successfully and neatly bring it into Revit so that you can prepare it for documentation from there. This is the part where I think you have to consider seriously at this juncture, or perhaps towards the end of this term. You must consider which program you really want to be using to document, because I think at some point in time you need to prepare some technical drawings here. With this, let's say we have modeled the form out nicely already. Okay, we need to prepare this model so that it can be read nicely by Revit. So these are the steps. Select the object, click on the big Max button, click on export, export selected. and you will choose this format here and give it a logical name. This logical name needs to be really this time around quite serious. So we are going to call it Organic Cabinet for Export from 3D Studio Max. The procedure works in such a way. Okay, we have the object from Max that we will port over to, we will export out to AutoCAD. And then we will do some processing to it, and then after that we will then export again over to then Revit. Alright, but the same thing, the troubling thing with this is these will all be in DXF format. DXF format is AutoCAD's native drawing exchange format. It is in a way an open source CAD format in this case. Other software vendors like Rhino, like SketchUp for example, or even MicroStation, they all write to DXF very, very nicely. So pay attention you guys, okay, at that. So therefore with this already, we will click save and we will look for this version. You can go dumb down all the way to AutoCAD 2000, but I prefer to use the newest one generation backwards, so that I hopefully can have most of the newer functions minus the new software's program bugs. So therefore we like to keep it at that. So I will choose AutoCAD 2010 DXF format. The rest we will just keep it as it is by default and click OK. What happens is the file has been written and is exported out. Inside AutoCAD, next we go into AutoCAD now, and we just start off a new drawing with no template. Just start off, open a new drawing with no template for this one. Just a blank file will do the job. With this, key in DXF in. Once you're done, look for this file, Organic Cabinet for export from 3D Studio Max, this one. Okay, key in and then OK. You will now begin to see the form. You can study it a little bit by holding on to the shift key and dragging the middle mouse button, so you can hopefully study the 3D form properly and make sure everything has been exported nicely already. Look, again, life is very, very easy when you have only this one little curvy line to export. Life is beautiful, but in your case, it can be a 45,000 face 3D model, I don't know. So life would not be so nice nor easy to export. Many a times you need to export them in pieces, in parts, or in layers, and not one shot, because there is a limit to how much faces one export command can do at one time. Usually about 32,000 faces, so be quite careful with this. Okay, now once you have this already, this is what we need you to do. Type in layer, LA, to build a new layer here. Call it Organic Cabinet, and then change the color to say color 6 for example. This is what I want you to do. Just add this one in, just in case. We'll explain why we need this later on. Okay, just add color 6 for this new layer here, or organic cabinet. Once this is done, select this object and now place it. Make this object by layer. The color is by layer. Make this object fall into organic cabinet layer. So it becomes like this. Once this is done, we are ready to move this one out. So we can now key in DXF out command. And then this time round, you will save it as this file name. Organic cabinet for export from AutoCAD. Okay, now with this, we'll save and overwrite this if necessary. So the part on exporting is done. Next, we are going to bring it into our project. Our project is here. Open up import export for students. This one. Alright. And before we do so, I just need to explain a few things to show you. Now, next part we're going to touch on this part on model in place. Okay. Model in place means you can almost imagine yourself trying to build. This is our project. The studio is our project. And then with that, we want to be building, say, this instructor's table here. But instead of building the instructor table in a new file or fabricated in an office or factory somewhere, we are going to build it in-house. That means we're going to build it right here at this point. Okay, which is inside the project. So if we go to architecture, components, okay, model in place, this is the part where it is. So if you click on this, the very first thing that pops out, Revit will be asking you, hey, which category do you want to be putting the object in, or you want to be building the family in? That is often than not one of the key consideration, what you should do, what you should not do. Now press escape to go back up first. I need to do some theoretical explanation so you know fundamentally how things work. Now key in this shortcut called VG first. When you key in VG, you will see a few things. You'll see this complex table down here. So I'll explain to you. This part here, this part of the table will highlight to you all the existing families. Now the Revit project file is essentially a compilation file that holds all the families. And these are the family categories all here. And they are broken into three things: the model category, the annotation category, and the import categories in general. Alright? And if you look across here, down here, you will see this table on projection. And this part, you will see cut. If you look across one of these objects, one of this family category, for example the casework category here, you will find that all these across here all are in white color. This whole table across, their cells are all white color. If you compare it against the furniture family category here, you will find that the projection or surface will be white color at this portion here. The portion on cut is now gray color. When it is in gray color, this is Revit's way of telling you, hey look, don't bother trying to change the lines or change the patterns or something, because this function is not there. What does this mean exactly? Yeah? Okay, just remember this. You have all white, you have some parts white, some parts gray. What does this mean? Now I have here one furniture item, two furniture items, okay, and both of them happen to fall under the furniture category. I have one section line cutting through these items. So what does this mean? By right, if I open up the section view, I will see these things being cut up. I will see the furnitures being cut up. But I don't. I only see the end elevation here, the side elevations, not cut up at all. This is the reason why this area in particular, it's being grayed out. I hope you understand this, so that you are conscious about your choices when you do your furniture family or you do your casework family next time round. Okay, so in essence, if you have classified initially when you are choosing your component, when you model it in place, and you have chosen furniture to be the family when you start your modeling, then you must be prepared that at the end of the day, when the section is being cut through, you will only see the side elevations. You will not see a cut through cut view in this case. That one. Alright. Then you might be saying, oh dear, I made the wrong choice, then put it in there, then die. Then how? It's not the end of the world once you have done this part of the work. Okay, just keep on doing until you finish the job, and then after that we will do the workaround. So how can we work around this situation? Now you join me. Okay, let's go to architecture, click on component drop down list, click on model in place. We know that furniture systems cannot cut section, it will not show up properly. So we are going to choose casework instead. Alright, but we are going to make that pool table cut a section, okay? Because just now when we model wrongly, let's say. So we are going to click OK, and then you give it a logical name. I think casework 1 is fine, so I'm going to just keep it at that and click OK. Now I'm going to scroll under, because I know that the pool table furniture family is inside already. So I'm going to look for, let's say, under furniture, I'm going to find pool table complete and look for 7 foot. This one down here. Can you find this? It will take a while, just in case. Okay, with this, all we need to do is we drag this here, and then I'll just put it here just to show you. Okay, just like that. Also notice when you have activated model in place, you have actually gone into the family editing mode. If you look at this now, does this look familiar to you? Alright, all these under create, all the modeling tools are here. Alright, and once you are done with this, you can click finish model. And now I want you to open up the section view again to zoom in to take a look. Now, open up the section view so that you can have a look at the section. Do you see anything looking different? This one, furniture category, right? The furniture family category, cut section also no use, you don't see it. But if this is also a furniture category, but it is actually nested inside the casework family, so now Revit recognizes it as a casework family. Now we can cut a section right through this. So actually no big deal, huh? Alright, it's just a matter of us nesting it inside another family category, and then it will show up already as it is. I hope you understand how this works here. Next, let's touch on the part on importing things. Okay, so go to the same thing, architecture, component, model in place, and with this same thing, we're going to click on casework. We are going to choose casework and click OK. OK. And if you look under create, you have the same set of tools, the same set of 5 modeling creation tools that you can have. We are not going to use any one of those for now, and instead we go to insert and we click on import CAD. With this, we are going to look for this file, organic cabinet for export from AutoCAD, this one. For the colors portion, we just let it preserve for now, although we can suppress it, but we're going to preserve it for now, and then leave everything as default, and then we click open. Do you now see that the custom piece that is modeled outside Revit is already inside here? You can do the same, you can just move them and so on, but I would like you to do a rotation using the rotate command. Once you have this, you find that you will be able to have a line that you can swing. I want you to point the rotation axis line to somewhere perpendicular. This is an arc, somewhere perpendicular to the arc itself before you turn it. Okay, once you have it near perpendicular, what's going to happen is, when all you need to do is just straighten it from here, and the line, the arc becomes very curved, so you expose a very long face to it. And I want you to position it somewhere here, where the wall, where this furniture piece will cut through the wall this way, intentionally, so we create problems that we can solve later on, like that. And once we are done with this, we will click finish model, and then we are done. If you now open up the section view again, you will now see this. Any one of you see a huge big mess or not? Like very messy black mess? somewhere. Very thick lines and everything. Not like this. No? Or all looks like that. Thick mess. Okay. Now, this is just to show you that this model, once you bring it inside under the casework family, it is sectionable already. So it can be cut, and this section can be seen quite clearly at that. But the thing is, it is not properly done. So we move on to the next part. How to change the import object model, line weight, and hatch pattern, and so on. Okay, these things here. So therefore, key in this shortcut called VG again. If you key in VG, a lot of things can be controlled and changed under the object styles. This button here is very important. So it will be good for you to remember the position here in the interface. This part. Now, click on this and go to imported object and expand on this. You will now see this part here. Remember, this is the layer of which we wanted you to create and put the object into prior to exporting out again. This one. Do you see that the color is magenta? That is the quality that controls the color of the object right now, which is magenta now. This is the part that controls the line weight, and let's try changing this one to black color from magenta and click OK. OK. Did yours turn black and white properly? Got? Can? Okay. Next, let's see. By clicking on object styles again under imported objects, if you click on this line type, let's see if we can change this. If you change the line type to say line type 7, what would you get then? Do you get something like what I have? Okay, the lines also become thick and everything. So that gives you an idea where you are actually setting the controls. Where can you create the controls for those things? Come, let's change this one back again under object styles. Change it back to line type 1 again, so that it becomes a light line at the back. Next, we will learn how to control the sections thickness, this sectional line thickness, which is essentially this one here. Okay. So again, key in VG, object styles. Look under this portion here. Okay. This part. This one controls the section thickness, and this portion here will control the hatch pattern. Okay. Hence, if we were to change this one to say line type number 4 and click OK, you find that the section line now looks thinner and it doesn't look so thick and heavy anymore. Okay. Do you see that right now the hatching is a cross hatch? Cross hatch is for block work, sawn timber, etc. Things like that. Alright. So let's say our object that is being brought in is not sawn timber, but it's actually concrete. This is built out of fiber reinforced concrete or glass reinforced concrete. So we will go into VG, object styles, and then click on organic cabinet material. It's somewhere here. You must click here before the button will appear. Okay, this part. So I'll screen capture this and show you. This is the part you click here. Once you click on this, this material browser will appear, and we are at the moment only interested in this portion here on the cut pattern, and we want to change the cut pattern to say concrete, and OK, and OK, and OK, and OK. Then nothing will happen. Okay, nothing will happen even though we have already updated the hatch pattern. Two things you can do to see the effect. Because it is an imported foreign model, so it will not update automatically. You must do two things. Either you save, shut down the program and restart, okay, or you can select the object and click edit in place, and then click finish model. Go in and come out one time, and then now you will see it happening this way. Okay, the hatch pattern will update itself after this. For example, now, let's say for example, the design concept is about penetration. So you start to see this whole furniture or this whole fixture that has been designed, creating the illusion that it actually crosses and cuts through the walls itself. But in reality, it never really cuts through. In reality, it is two different pieces of units, but aligned and mounted or installed at the wall itself to create the illusion that it actually cuts through the wall. So when you document this, you cannot possibly show things like that. In MedTech and design presentation, this is an absolute no-no. But in 3D modeling, you want to be able to do that because you will save a lot of work. Rather than building two pieces, you just build one piece and let it cut through and let it stay that way. Let's say, okay. So in Revit, we will touch this portion up by using the liquid paper technique. So we'll just create the liquid paper to cut this off. How? We will click on Annotate. This is the part where we use 2D to touch up what is lacking in 3D. Okay? To model this part in 3D, it would have been very painful and difficult. But we can simply use 2D to touch up this portion. Under Annotate, click the drop down list for region, look for masking region. We are trying to create liquid paper so that we can touch it up, alright? So we will select this portion here, and then we will use the rectangle tool to mask it off like that here. Okay, once we have this, I want you to see the effect. Click on finish. Do you now see there is a white masking tape patch over there? This one. Okay, this part is being covered up already, but it still doesn't look very real because there are lines that shouldn't be there appearing at this point. So what's going to happen is we are going to select this masking tape, click on Edit Boundary. We are going to select the top and the bottom line here, and we are going to change it to say invisible lines and click Finish. Okay, once we have this, it looks like it's now patched up, and we can begin to use detail lines under Annotate Detail Lines to draw in manually the lines of the wall sections here. and then we will begin to change the thickness of the lines to say 0.2 to create the wall. And then we will use more detailed lines here to create the illusion of the hatch pattern that we can copy down. And we can use copy again to build one or two more so that we create the illusion of the finish. So with this, you would have cleaned up your work quite nicely, and then you would not only satisfy the technical requirements, but you also satisfy the drafting requirements as well at that for this. Okay, that's one area you can use at that. Second part, I need to explain to you there are certain limits to what you can do with this particular function. So you must be quite careful what you can bring in, how to model this whole thing all together here. Like for example, can you click on edit in place one more time? Go back to plan here. Under create, click on extrusion. Extrude something. So just extrude a rectangle block, but it must cut through the section. Okay, the section must cut through this block here, something like that, and you click finish. So we look at this now. Do you now see that there is a section like this? Many a times when you model a furniture piece or a fixture piece, you don't use the same line weight for the one object in a section. Okay, let's say sometimes this one when you section is thinner, this one when you section is thicker. What happens if things like that would happen? If they are all inside the same family class, all of them will look with the same thickness because they all fall under the casework family here. Alright, if you click on object styles, we have a problem. The issue being the imported object here cannot be changed. Okay, now we are going to attempt to make this under the same family, but they will have different line weights. How to do this? Notice if you go to VG, under casework, if you expand on this, you now see you have the casework main family here. You also have the subcategory here, 1 and hidden lines, let's say. That's what we are going to use. So select the object, click on edit in place, and select this new extrusion here. You will find that when you select this, under properties you have identity data here, in which there is a subcategory you can use. This subcategory here is actually referring to some of these subcategories here. We are going to use, let's say, 1, and then we click finish model, let's say. Do you now see that the line is different in terms of the line weight thickness? It's now different, primarily because under object styles, okay, casework is set at line width 4 when cut. However, subcategory 1 is set at 6, line type 6. So therefore, when you change the line type, it becomes bigger. Okay. However, this cannot be applied to the imported object. This imported object here, alright, cannot be changed. So we have no, even though we change it to subcategory 1 here, okay, the line weight doesn't change at all. The line weight is still controlled by the main category, which is here only, this part. So this is the limitation of Revit right up to now at this point. So foreign imported objects, yes, it can cut sections, but you will lose one category's line properties, line weight categories. So when you're doing this, if you have a few types, then perhaps you need to start putting them in different family types already at that. Okay, please take note of this. Next, let's say if this is not built out of concrete, you need to add in more details. Alright, that may not necessarily mean that you kill yourself modeling every single component out. No, don't do that. Okay, there are better ways or more efficient ways to do this. You can simply just go to object styles and change this to no pattern. Alright, and then from here we can look at under annotate, draw in the details from this part again. So we can literally straight away just draft this out. Okay, with this we will be able to fill in the blanks with some of these details, and by changing the line weights so that we do not have to go through this whole painful process of modeling everything out this way. Alright, I hope we are quite clear about how to work this part already by now.